In the last period, we have studied about the problems on the self-inductance and mutual inductance. In the today's lecture, we have to consider another type of problem, that is a car spark a coil of EMF is given here. You know that EMF is denoted by the symbol is E. E is equals to 40 kilovolt. 1 kilovolt is what we have to say, that 40 into kilo means 10 raised to power 3 volt. This is we have given. And when primary current changes from 4 ampere, that is DI, 4 ampere to 0 ampere, means DI is equals to what? 4 minus 0, that is equals to what we have to say, that 4 ampere is given. And in a what time we have? It is 10 microsecond. Micro means 10 into 10 to the power minus 6 second. Find mutual inductance in the primary coil. Again we have same formula, that is E is equals to M into di by dt. A minus sign is there, and that is equals to, we have to say that this can be written as M is equals to E upon magnitude of di by dt, and that is equals to, E is nothing but what we have to say, that 4t into 10 raised to 3 divided by di is what we have to say, that 4 divided by dt is nothing but 10 into 10 raised to power minus 6. Here 4 1 is 4, 4 4 is 40. M is nothing but 4 into 10 raised to 3 divided by, this can be here 1 by this one, and that is what we have to say, that 10 into, this can be written as a 40 upon 1 multiplied by 10 into 10 to the power, what we have to say, that minus 6, and finally it gives that this is what 4 is as it is, this is 4, means 4 into 10 to the power minus 2. 4 into the power is what? Minus 2, and finally it gets that nothing but what? 4 into 10 to the power, what we have to get? Answer is we have given here 0.1. How it is? Oh, sorry. 4 1 is 4. That is 40 as it is. 4 into 10 to the power minus 2. Sorry, here 10. 4 1 is 4. 10. Here also we have 10. And it is what we have. Finally, this is what? 10 to the power minus 1. Means we have to say that 0.1 Henry. This is the answer, right? This is 3 plus 1 4 plus 1 5, 10 to the power minus 1 is nothing but 1 by 10, and 1 by 10 is nothing but 0.1 Henry. Now second problem we have, when the current through the coil is changes at the rate of दिलेला आहे. What is the rate now? di by dt. It given that 0.2 ampere per second, and EMF is we have given 5 millivolt, and this is what we have. E is equals to 5 milli means 10 to the power. Here we have at the 5 millivolt. This is nothing but 5 into 10 to the power minus 3 volt. Calculate the induced self-inductance. We have to calculate first of all L, And what will be the magnetic induction, that is magnetic induction, sorry, what will be the flux of magnetic induction phi किती असेल when the current is flowing through the circuit is 0.5 ampere. First of all, we have to calculate the L, that is E is equals to minus of L into di by dt. Substitute the value first. Therefore, L is equals to E upon magnitude of what we have, di by dt. This gets E is equals to, sorry, L is equals to, what is the value of E now? 5 into 10 to the power minus 3. This divided by di by dt. That rate is 0.2 ampere per second. And finally it gets that 50 by 2, 10 raised to minus 3. And that is equals to what we have to say, that L is equals to 25 millihenry. This is nothing but a coefficient of self-inductance. And phi is equals to, what is the formula? Phi is equals to L into I. I is we have given here, L is we have to known. So phi is equals to, L is nothing but 25 into 10 to the power minus 3 into I is nothing but what we have, 0.5, 125, that is 12.5 into 10 to the power minus 3 Weber. This is the answer we have. 12.5 is Weber. This is considered as a phi is equals to L into I. L is given and the current is what we have, 0.5 ampere. So it gets that 12.5 Weber is the unit of a magnetic flux. Now, one more problem we are going to discuss here. Using Maxwell's equation, which equation? That is last equation. Curl of h bar is equals to j bar plus dou d bar by dou t. Prove equation of continuity. Now, we have given here Maxwell's fourth equation. How many? What we have? That is curl of h bar is equals to j bar plus dou d bar by dou t. Taking divergence both sides, what do you have get that? Divergence of curl of h bar is equals to divergence of j bar plus dou into by dou t into divergence of d bar. But divergence of curl of h bar is nothing equals to 0. Therefore, 0 is equals to divergence of j bar plus dou d by dou t into divergence of d bar. But divergence of d bar is equals to rho. Therefore, divergence of j bar plus d rho by dou t, that is equals to 0. This is equation of continuity. Equation of continuity. In this way, we have to prove the equation of continuity. Like that, we are given some problems on the Maxwell's equation also. one equation is given and another equation can be proved by using that. One more problem, we have to derive the equation of continuity from the last Maxwell's equation. Also, we have to calculate the self-inductance, mutual inductance, then induced EMF when they are connected in series. At that time, we have also considered total EMF of the circuit can be calculated. Flux can be calculated, phi is equals to L into I. These are the very simple problem. Many times question will be asked on this topic for what you have to say that 5 marks for one problem is there, very important every time. That's why we have to solve that problems. E is equals to L into di by dt, or E is equals to M into di by dt, or phi is equals to L into I, or 4 Maxwell's equation, divergence of D is equals to rho, divergence of B is equals to 0, curl of E is equals to minus dou B bar by dou t, divergence of H bar is equals to J bar plus dou D bar by dou t. These equations are very important, solving these problems from that equation, and this way this topic is finished. Today we have, in the next lecture we have to start one more new topic, that is third or fourth. Thank you.